So today, since we have discussed what is a layer 2 header or an Ethernet frame header and a layer 3 header or the IPv4 header, now it is important for us to understand one, not one, two important features in networking. Okay, they are the most important features in any network engineer's life also. We will come across these two features frequently. Okay, 99% of the time we will come across these two features a lot, and that is ping and ARP. Ping and ARP. These two are the features that we will always come across. Okay, so just to give you an example of what a ping is, let me just take you to the GNS3 simulation and show you a ping. Okay. So we have already done a lot of ping in our earlier labs, be it what do you say, VLAN, especially in a VLAN side, we did a lot of ping from one PC to another PC. Okay, so we did not discuss what is a ping, and also we did not discuss what is an ARP. So in today's section or session, we will discuss what does a ping do and what is an ARP do. So let me quickly assign IP addresses on R1 and R2 alone. We are not going to discuss R3 as of now. So I'm just using R1 and R2 over here. Okay. So configuration terminal interface fast Ethernet 0/0 IP address 12.0.0.1 255.0.0.0 no shut. No shut. Then on R2 configuration terminal interface fast Ethernet 0/0 IP address 12.0.0.2 255.0.0.0 no shut. Okay. So now on R1, from R1, let us try to ping R2's IP address. Ping is the command ping 12.0.0.2. And let me also capture this packet. Or what I'm doing is I'm capturing the information that we will be discussing in the ping and ARP. Right? So ping. Okay. So we saw some information present, and we saw success rate is 80%, 4 out of 5, right? And then everything is going good. Then let's try to ping once again, and this time we will see the success rate as 5/5 or 100%. Okay, so let's go to Wireshark. Okay, and see what happened. All right. Now, before I explain this whole section, let's start our discussion on ping and ARP using these two routers only. Okay. So we have R1, R1, okay, connected to R2. All right. R1's IP address is 12.0.0.1. R2's IP address is 12.0.0.2. Okay. Now, when I do a ping, ping is an ICMP protocol. ICMP protocol, meaning that Internet Control Message Protocol. Internet Control Message Protocol. This is what the full form of ping is. Ping is an Internet Control Message Protocol. In other words, it's a connectivity check feature. It's a connectivity check feature. We are trying to check the connectivity between the two routers, R1 and R2. We mainly use ping to check the connectivity between any two routers. Okay, and Ping is an ICMP protocol, Internet Control Message Protocol. Okay. Now, when we do a ping from R1, when I do a ping of 12.0.0.2, so what is happening? What R1 does is R1 will create an IPv4 header, okay, or a layer 3 header, okay, with a source IP. What is the source IP here? Source IP is going to be 12.0.0.1, correct? Then a destination IP is created, which is 12.0.0.2, right? Then this IPv4 or layer 3 header is encapsulated inside your Ethernet header or your layer 2 header. Okay. And in that layer 2 header, you will have a source MAC, which will be of R1's R1's MAC address. And then the destination. However, R1 does not know the destination MAC of this IP address. It does not know the destination IP of this MAC address. So basically, if you see, this is your ICMP packet. This is your ICMP packet. However, this ICMP packet is incomplete because R1 does not know the destination MAC or R2's MAC address. Okay. So what it does, it will keep the ICMP packet on hold. Okay. And when it keeps this ICMP packet on hold, you will not be sending any ping messages or ICMP messages. And that is what we saw here. This single dot that you see over here is what R1 tried to do first. It tried to ping. However, it came to know that there is no destination MAC address. And that is why you see a dot over here, a dot over here. Okay. And behind that dot, what is happening? ICMP is kept on hold. Okay. Now, why is it kept on hold? Because the router does not know the destination MAC of R2. So it needs to find the destination MAC of R2. And to find the MAC address of any device which has an IP address. Okay. To find the MAC address of a device with an IP address. Okay. We use a special feature has been created. That feature is called as ARP. ARP's full form is address resolution protocol. Address resolution protocol, ARP. Okay. So what ARP does, it will find the MAC address of a device which has an IP address. So over here, R2 has an IP address. In R1's ICMP packet, there is a destination IP. But for this destination IP, there is no MAC address. And hence, when there is no MAC address present for the destination IP, R1 will generate an ARP packet, ARP resolution or address resolution protocol. Okay. So address resolution protocol is another layer 3 data. It's a layer 3 protocol. It's a layer 3 protocol. Okay, it is a layer 3 protocol. So the format of a layer address resolution protocol looks like this. Okay. So in an address resolution protocol format, it will also have a layer 3 information, which says we have an R1. Okay. Okay, before I move on, any question till here?
No, sir.
12.0.0.1, 12.0.0.2. Okay. So an ARP is generated. When an ARP is generated, ARP has a layer 3. In layer 3, it will create a layer 3 frame or a layer 3 packet. At layer 3 packet, it will find the information of source IP, which is 12.0.0.1. Then a destination IP. The destination IP is 12.0.0.2. Correct. Then it will ask for the source MAC address. Source MAC address is R1's MAC address. The destination MAC address is also present. The destination MAC over here will be all zeros. All bits of the destination MAC will be zeros. And it will have an ARP request, of 1. Okay. This is the layer 3 header of an ARP packet. This is a layer 3 header of your ARP packet, which has a source IP, destination IP, source MAC address, destination MAC address, and ARP request as well. In the layer 3 header also, you have a source MAC and a destination MAC field also. Okay. Yeah. Then this layer 3 header is then encapsulated inside a layer 2 header or an Ethernet header, which again has a source MAC. Source MAC is R1's MAC address, and the destination MAC now is a broadcast MAC address with all digits as FFF. This is basically your ARP packet. So let me open up the Wireshark. Okay. So the moment I did a ping, okay, R1 tried to create an ARP packet. Okay. And you can clearly see here. R1 generated an ARP packet. Okay. Let's check R1's MAC address. Show interface. Okay, fast Ethernet 0/0. So you can see here for fast Ethernet 0/0, this is the MAC address. Okay, CA01, CE28, 0008. You can see here CA01, CE28, 0008. So R1 has created an ARP packet. Okay, and what are the information present in the ARP packet? Let's open. See here, ARP. Please understand, ARP is not an IPv4 packet. It is not an IPv4 protocol. It is not an IPv6 protocol. It's neither. It's a separate protocol in itself. All right. It's not an IPv4. It's not IPv6. It is a separate protocol. Okay. Now, in the ARP, we just mentioned, in the ARP packet, it will have a layer 3 information. It will also have a layer 2 information with source IP, destination IP, source MAC, destination MAC, etc. So let me open up Wireshark. I'm not sure in Wireshark will it provide all the information. But let's check that. Yes, we have the information. Okay, so you can see here, sender IP address is present. Source IP, that is what we were looking for. 12001, correct? Then destination IP address, target IP address, 12002 is present. 12002 is present. Then source MAC address, that is R1's MAC address. We can see here R1's MAC address, correct? Then destination MAC address. As I said, the destination MAC address is 00000, and you can see a target MAC address 000, all zeros, right? And the ARP request number, that is 1. You can see a ARP request number is 1. Opcode is request, that is 1. So this is how, or this is what your ARP request or ARP message would look like. Clear? Any question?
No, sir.
Okay. Now this ARP header is encapsulated inside your layer 2. Okay. So you can see this ARP header is inside the Ethernet header. You can see here Ethernet header, and in that Ethernet header we can see source. We have a source MAC, correct? We have a source MAC, which is R1's MAC address, and a destination MAC address, which is FFF. You can see here source MAC is R1 and destination MAC is FFF, which is broadcast. Now you may ask, why is it a broadcast? Why is it a broadcast? Okay, it is a broadcast because, as I said, R1 does not know the MAC address of R2. So it basically does not know where to send, who to send, until and unless it has a destination MAC address, okay, it cannot simply forward the data to any router. And if it has to forward the data to any router or any switch or any networking device, the only way for it to do is using a broadcast. So what will happen if there is a switch connected and there are multiple routers connected? Okay, R1 does not know which router has the IP address of 12.0.0.2. R1 does not know which router will have the IP address of 12.0.0.2, and that is why it sends this as a broadcast. So ARP is sent. Okay, if it is received by the switch, switch will read the layer 2 header, which has a broadcast MAC address, and it will forward to all the routers in the network. And eventually, the router which has the IP address of 12.0.0.2 will receive it. And that is the purpose of having the layer 2 MAC address as broadcast in the layer 2 header of a ARP packet. Clear? That's the reason of having a broadcast MAC address. Any question?
No, sir. Clear.
Right. Now, again, we saw one more thing which I did not mention over here, the type field. Type field is telling it is an ARP packet. We just had a discussion last night. The type field mentions what kind of layer 3 information is being carried. Okay, and let me open up over here. See the type field in the Ethernet header. Type field in the Ethernet. It says ARP packet. It is carrying an ARP packet inside it, and that is what we just saw. Okay, so your layer 3 ARP is encapsulated inside your layer 2 Ethernet header, and in the type field it mentions as an ARP. All right. So with all this information, R1 sends this ARP packet with the expectation that whoever has the IP address of 12.0.0.2 will eventually receive. And let's assume R2 has received this ARP information. When R2 receives this ARP information, obviously it is going to read the layer 2 header first. And in the layer 2 header, it reads the MAC address, the destination MAC address, which is all F. That is a broadcast. That means R2 will understand that this is not just for me, it is for every device in the network. If it is a broadcast packet, let me check the type field. It says that the type field is an ARP. Okay, is the ARP for me? If I have to verify if the ARP is for me or not, I have to open the layer 3 header. I have to open the layer 3 header. So it will, R2 will read the broadcast MAC address. Then it will read the type field, which says ARP packet. So it will understand that it is an ARP packet. But to verify, is the ARP for R2 or for any other device? It needs to open the ARP packet. So it opens up the ARP packet. And in the ARP packet, it sees an ARP packet is received from the source IP this for a destination IP 12.0.0.2, which is R2's MAC, which is R2's IP address. Correct. And it is coming from a source MAC this, and it is an ARP request. That means this guy 12.0.0.1 is requesting to know my MAC address. Okay, source IP 12.0.0.1 is requesting my MAC address. And how do I know it is my MAC address? To the destination IP. This is my destination IP only. R2 sees that it is my destination IP. That means this ARP request is for me. All right. So everything is checked by R2. R2 sees that the layer 2 header is a broadcast header. So it checks the type field. It says that it's an ARP packet. So to know if the ARP packet is for R2, it needs to open up the layer 3 header. When it opens up the layer 3 header, it sees ARP information. And in that ARP information, it sees that an ARP request is sent to 12.0.0.2, which is R2's IP address. Correct? So R2 is now confirmed that this ARP request is for me. Now R2 has to respond. R2 has to respond for this ARP packet. Correct? when R2 responds, R2 will again create a layer 3 header. R2 will again create a layer 3 header or an ARP packet. In that ARP packet, it will have the source IP of 12.0.0.2, which is its own IP address. Then a destination IP, which is R1's IP address, 12.0.0.1. Source MAC. In this source MAC, now R2 will mention R2's MAC address. And the destination MAC, it already knows destination MAC from here. So that is R1's MAC address. Okay. Now the ARP will be ARP response. ARP response of 2. This is your layer 3 header or your ARP packet. This is your ARP response, you can see. ARP response. Then this ARP response is encapsulated inside a layer 2 header with a source MAC of R2's MAC address and destination MAC of R1's MAC address. Okay, and again a type field of ARP. Let's open up the response. See over here, there's a response. And in that response, we can see layer 3 as the address resolution protocol. Sender MAC address, this is R2's MAC address. Sender IP, this is R2's IP address. Destination MAC address, this is R1's MAC address. Destination IP, this is R1's IP address, which is encapsulated inside a layer 2 header with the destination MAC address of R1, source MAC address of R2, and type field as ARP. Clear? Any question?
Yes, sir. Actually, if you have any router in between R1 and R2, ARP request number will change or it will be one.
Let me complete this particular scenario. Okay.
Okay.
And then
Okay.
I will explain if there are multiple routers in between what.
Okay, sir. Okay.
So again, there's no question or doubt over here, right? With this.
Yes. No. Sir.
Now ARP response is created. Okay. What is the value of ARP response? Let's check. ARP response values 2. ARP response values 2. So it R2 sends the information. Now when R2 sends the information, what R1 is going to read? R1 is going to obviously read layer 2 header first. So it will see that data has come with a source MAC of R2 and destination MAC of R1, which is my address, this is my MAC address, R1's MAC address. Okay, this packet is for me. And what kind of packet is it? It's an ARP packet. It is an ARP packet. Oh, yes. So R1 sees that, okay, I had sent an ARP request. Maybe I'm receiving a response for this ARP packet. So let me open up the ARP packet. It opens up the ARP packet. So it sees a source IP of R2, its own destination IP, R1's own IP address, source MAC, R2's MAC address, which is what it wanted, and destination MAC of R1, and the opcode as response. So now R1 now knows that R2 has sent back the ARP response with its own MAC address. R2, which has a destination IP of which has an IP address 12.0.0.2, has sent the ARP response with his own MAC address. So now R1 now knows R2's MAC address. Correct? This is the whole procedure of ARP, where the two devices now know about each other's MAC, or R1 knows about the destination IP's MAC address. This is ARP, address resolution protocol. Okay, now R1 with the help of ARP, knows the MAC address of R2, right? So now the ICMP packet which it had kept on hold, is now complete, where now R1 knows about the destination MAC address, where R1 now knows about destination MAC address. Your ICMP or your ping packet is complete. Now this ping packet can be sent. This ping packet is sent to R2. R2 receives it. When R2 receives it, okay, here the type field. Type field is going to be an IPv4 ICMP. Okay, let's go over here. See here, this is an ICMP packet. You can see this is an ICMP packet. Okay, so 12001, which is R1's IP address, is sending a ping packet or ICMP packet to 1200. So layer 2, in layer 2, you will have source MAC as R1's MAC address, destination MAC as R2's MAC address, and type field as ICMP or IPv4. Okay, so you can see here destination MAC address, source MAC address, and type field as IPv4 as an IPv4 packet. All right. Now inside this IPv4, we will have the source IP address 12001, source IP 12001, destination IP 12002, destination IP 12002. Now inside this IPv4 header is your ICMP message, the ping packet or ping request. Code is 0. Okay. So let me remove this. Let me draw it a better way. ICMP packet is created with a source IP of 12.0.0.1, a destination IP of 12.0.0.2. Okay. Then this ICMP packet is encapsulated inside your IPv4 header, which has a source IP again of 12.0.0.1, destination IP of 12.0.0.2, which says the protocol as ICMP. Okay, this protocol field is similar to your layer 2's type field. Layer 2's type field. Okay, then this IPv4 packet is encapsulated inside your layer 2 header with a source MAC of R1 and destination MAC of R2, which it got from ARP. So this whole is your data now. This data is now sent to R2. Okay. Any question about the data formation?
No, sir.
Now, when R2 receives it, what R2 is going to read? First, R2 will read the layer 2 header first. Okay. In the layer 2 header, it will see its own MAC address, correct? And in the type field, it will see an IPv4 packet. So let's open up Wireshark. Destination MAC address is R2's MAC address. Source MAC address is R1's MAC address. Type field is IPv4. Okay. Now it's an IPv4 packet. So now what R2 will do? R2 will open up the layer 3 header. When it opens up the layer 3 header, it sees a source IP of 12001, a destination IP of 12002, and a protocol field which says is an ICMP packet. That means the ping packet. It's a ping request. Okay, it's a ping request. So over here, IPv4, a source IP and a destination IP, and the protocol field ICMP. ICMP. That means the ping packet. Is it a ping request or is it a ping response? I have to open up. Okay, so it opens the next packet. It opens the next header, ICMP header. It sees 12001, 12002, and the code as 0. Okay, which is the ping request code, that is 0. So R2 now knows a ping request is received from this source IP to me with an op code of or an ICMP code of 0. That means it's a ping request. All right. Any question?
No, sir.
Now, what R2 will do? R2 will respond to this ping request with a ping response or an ICMP response. Correct. So again, it will create an ICMP header, which will have a source IP of R2's IP address 12.0.0.3, a destination IP of R1 12.0.0.1 with an ICMP response code of, I think, 8, if I'm not wrong. Okay, I'm sorry. I'm extremely sorry. This ping request value is 8. Ping request value is 8 and ping response value is 0. Ping response value is 0. Alright. So ICMP packet is created. This ICMP packet is then encapsulated inside your IPv4 header. Okay. Which again has a source IP of 12.0.0.2, destination IP of 12.0.0.1. Okay. And a protocol field which tells this is an ICMP packet that it is carrying inside IPv4 header. And then this IPv4 header is encapsulated inside your layer 2 header, which has a source MAC. Source MAC is of R2, destination MAC of R1, and a type field which says IPv4. This is the response message from R2. Let's open up here. So destination MAC, you can see this is from R2. You can see 12002 is R2's response to R1. All right. So destination MAC is R1's MAC address. Destination MAC, R1's MAC address. Source MAC address, R2's MAC address. Source MAC address, R2's MAC address. Then type field, IPv4, IPv4. Right. Then this layer 2 header is encapsulated inside your layer 3 header or an IPv4 header. Okay. Which has a source IP of 12002, source IP of 12002, destination IP of 12001, destination IP 12001, and the protocol field which says ICMP. Protocol field which says ICMP. Clear? This IPv4 packet is then encapsulated inside your ICMP packet. Okay, ICMP packet which has a source IP. Okay, here there's no mention of source IP. There's no mention of source IP. It's okay. So, okay. There's no mention of source IP. It only mentioned is it an IP ICMP request or ICMP response. The source IP and the destination IP can be found by the routers in the IPv4 header. Okay. So this IPv4 header is encapsulated in ICMP. In this ICMP, it says ICMP response as 0. ICMP response as 0. Type as 0. In ARP, for ARP, it's the code that matters. ARP code. See here, opcode request and opcode reply. But in ICMP, it's not code. You will have a code value also. No, we are checking the type code, not the opcode, but the type code. This is ping request and ping reply. 0 is ping reply. Clear? Now this ICMP packet, is sent back to R1. When R1 receives it, R1 first is going to read the layer 2 header. It sees that I have received a data with a source MAC of R2 and a destination MAC of R1, which is my MAC address. And the type field is IPv4. So let me open up the IPv4 header. In the IPv4 header, source IP is mentioned, destination IP is my IP address, and it's an ICMP packet. Now, is this ICMP response or is it an ICMP request? So let me open up the ICMP packet. In that ICMP packet, it's an ICMP response with a code of 0. That means this guy is responding to my ping which I sent. It is responding to this ICMP request that I sent. That means my connectivity with R2 is okay. He can hear, he can listen to my ping, I can listen to his ping. That means the connectivity between me and R2 is okay. And this is how your ARP and ping works every time you try to make a connectivity between any two devices. So coming back to our ping output over here, the moment I did a ping of 12.0.0.2, this dot that you see here is basically the ARP resolution that is happening behind. R1 is sending R2 the ARP request, asking its MAC address. And once the MAC address is found, you will see 4 successful pings. 4 successful pings. Now the next pings are all success. Okay. So if I just do ping 12.0.0.2, we will never see an ARP resolution. ARP resolution happens only once. ARP resolution will only happen once. R1 knows about R2's MAC address. It will never create ARP again. It will never ever create ARP again because now it knows R2's MAC address. So it will directly start to ping. And this is how your ARP and ping works. Any question?
No, sir. Actually, uh, may I know like why it is ICMP request is 8 and reservation number is 0?
What? That's how it has been designed. Like,
Previously,
that's how it has been designed. So I can't say
okay,
anything why. That's how it has been designed. So in ARP resolution,
okay,
the request code is 1 and a response
mhm,
code is 2. But in ARP, the request code is 8 and the response code is 0 for ping.
is 0.
Okay.
Okay,
Why? Even I don't know. That's probably that is how they have designed.
okay, sir. Okay.
And to answer your question, what if there are multiple routers in between? Right? You had this question, correct?
Yes.
So let's say you have R1, R2, R3. We try to ping R3's IP address. That is, this is 12.0.0.1. This is 12.0.0.2. This is 23.0.0.2. And this is 23.0.0.3. Okay. We try to ping 23.0.0.3. Okay. So when an ARP is created, okay, ARP, if you remember the MAC address in ARP or the layer 2 MAC address was all broadcast. Okay. This broadcast packet cannot go beyond R2. It cannot go beyond R2. It will be circulating here only. Okay. Or if there is a switch in between, if there is a switch in between, it will go to these routers only. It will never cross these routers or beyond these routers. All right. Now, if in such scenarios, what is going to happen? R1 will never be able to reach R3. Correct? R1 will never be able to reach R3. Right?
Yes.
In this scenario, R2, what R2 does, R2 will do a proxy R. It will do a proxy R. What is a proxy? We have done a lot of proxy in our college. Right? When our friend is absent, right? We instead of our friend, we will give attendance for him. Correct? That's what basically we do
Yes.
for proxy. Similarly, when R1 generates an ARP packet, when R1 generates an ARP packet for R3, it will be received by R2. Correct?
Yes.
Now, what R2 will do, R2 will never forward this ARP to R3. It can never forward that ARP to R3. It will send back a proxy ARP. It will send back a proxy ARP, where instead of R3's MAC address, it will mention its own MAC address. It will mention its own MAC address. That means it will say you 23003's This is the destination IP. For 23003, the destination MAC is R2's MAC address. This is how it will respond to R1. Okay,
Okay.
this is how it will respond to R1. Now, in R1's ARP resolution, how will it ICMP packet? How will it see? It will have a source IP of 12001, destination IP of 23003. Okay, source MAC of R1's MAC address, destination MAC. It thinks R2's MAC address is the MAC address of R3. This is how it is created. Now this packet is sent to R2. Okay, R2 will receive it. Okay, R2 will receive it. R2 will read the layer 2 header. It sees its own destination MAC address. Correct? It will see its own destination MAC address. So R2 will assume this packet is for me. It will open up the layer 3 header. And in the layer 3 header, it will see the destination IP. That time R2 will realize that this packet is not for R2, it is for R3. When R2 sees this, it will again create a new packet with a source IP of 12.0.0.1, destination IP of 23.0.0.3, source MAC. Now, here the source MAC and the destination MAC will change every time your data moves between routers, the source MAC and the destination MAC will change. Previously, the source MAC over here was R1's interface IP address. Here, this was R1's interface IP address. Here, this was R2's interface IP address. Now, when R2 forwards this data to R3, the source MAC now is going to be R2's interface MAC address, and the destination MAC is going to be R3's interface MAC address. And this data will be then forwarded to R3. R3 will receive it. It will see its own MAC address. It will see its own IP address, and it will respond in a very similar fashion. This is what R2 will do. It will send a proxy ARP.
Okay.
Clear?
Yes.
Any doubts? Your yes had some confusion or some doubt.
No,
You can
no.
ask.
It is yes. That request number is there, right? Will it change or not?
No. It will still remain the same.
Okay.
See, as I said, ARP is not going towards R3.
Yes.
ARP is sent to R2. R2 is not forwarding it to R3. It is sending back a response. And in the proxy ARP, it's just the name is given. It's not a
Yeah.
new feature. The request, the code will remain the same, 0 and 1.
Okay.
ARP request will be 0. ARP response will be 1.
Okay. So it will be constant.
It will be constant.
Okay. Yes, sir. Understand.
Okay.
Yeah.
Now, since you have asked for proxy ARP, let me discuss one more ARP, which is a very important ARP. It is called as a GR. Gratuitous ARP. Gratuitous. Now, to understand gratuitous ARP, many people get confused. What is gratuitous? Or they don't even know how to pronounce this. Okay, it's basically GRATITUOUS. Okay, many people pronounce this as gracious ARP. No, it is not gracious. It is gratuitous ARP. Gratuitous ARP. Okay, gratuitous ARP. Now, to remember what does gratuitous mean, think of the word gratitude. Gratitude. I hope you know what does gratitude mean.
Yes.
Right? It means being humble. Okay, being very down to earth, being very simple, calm, polite with people. Gratitude. Or you feel very honor about some people. You have respect for other people. That's basically a mixed emotion. That's what you basically
Yes.
call as gratitude. That's the exact work of art. gratuitous art. It's basically a gratitude art. And how is that gratitude art? Let me tell you that. So imagine a PC1 connected to a switch, PC2, PC3, and PC4. Okay. Now, when I assign an IP address to PC number one, we all know that a networking device, any networking device, has a MAC address built inside. It's hard coded. You cannot change it. So PC number one already has a MAC address for it, correct? Some MAC address. Now, when I assign an IP address to it, for example, 10.0.0.1 is the IP address. So what happens? This IP address gets binded with this MAC address, correct? This is the MAC address and this is the IP address. It gets binded. Now, PC1 out of gratitude, PC1 out of gratitude, what it does, it will send a GR saying that, hi everyone, my MAC address and my IP address is this. It will send it to every PC. This is my MAC address and this is my IP address. So now PC number 3 knows about PC1's MAC address and IP address. PC2 also knows about MAC address and IP address. PC4 will also know about PC1's MAC address and IP address. This is what gratuitous ARP does. Any networking device will automatically send its own MAC address and IP address and advertise it to the other devices in the same network. Thereby, all the other devices in the network knows about the MAC address of this networking device. So with this, what happens is that when PC number 3, with gratuitous ARP, what happens? PC number 3 knows about the destination IP, that is 10.0.0.1. It also knows about the destination MAC address of this IP address, that is 1111. So when PC number 3 pings, when PC number 3 pings 10.0.0.1, there is no need for an ARP to be created by PC number 3. Got it? There is no need for PC number 3 to create an ARP because it already knows about the destination MAC address. That is what gratuitous ARP does. Clear?
Yes, sir. Clear.
So in the interview, they may probably ask, do you know different types of ARP? Okay. So basically, it's one is the basic ARP. The other is a proxy ARP. Okay. Proxy ARP and ARP, the functioning of proxy ARP and ARP is same. Okay. The only thing is, instead of the destination device, some other device will respond to the ARP. And then we just saw what is a GM. So these are the three main ARP that they may ask in the interview.
Okay, sir.
Okay.
Yeah.
With this, we are finished with ping and ARP. And from tomorrow, we'll start with routing protocols. One of the major routing protocols, that is OSPF.
OSPF.